Hey physics students, I'm going to show you in this video two ways of solving a problem like this one right here. We've got two people, we have Bob and we have Carl, and we're told Bob starts 5 kilometers west of the school and heads east at 4 kilometers per hour, and Carl begins 10 kilometers east of the school and heads west at 6 kilometers per hour. We want to know when and where do they meet. The first thing to do is to just identify numbers that we can use and directions that we can use. So I see Bob here begins 5 kilometers west. That's a position. And he moves east at 4 kilometers per hour. That's a velocity. So I could make a little system like I'm going to make a square around positions and I'm going to make a squiggle under velocities. If that helps you keep track, you can try that. And I see that Carl here begins 10 kilometers east. So I think I'm going to use positive for east and negative for west. So this will be a negative position. This is a positive position. Here this is east, so this is a positive velocity. And for Carl, his velocity is west. So I know that that's a negative. So now we can set up some equations for these two characters. I'm going to label them. Here's Bob, here's Carl. And I want to know how their positions relate to time. So for Bob, I know his position is going to begin at -5. And how quickly does he change that position? 4 kilometers per hour. So if I measure my time in hours, I can say this is plus 4 times t. Now for Carl, I also have an equation for position. Where does he begin? He begins at 10, and then we're going to be subtracting some amount. If I measure my time in hours, remember t here is going to represent hours, then I'll say his time decreases 6, his position decreases 6 for every hour that goes by. So now the thing we want to know is when these are equal to each other. So if this x equals this x, if the left-hand sides are equal, then I know the right-hand sides must be equal too. So setting the right-hand side of the Bob equation equal to the right-hand side of the Carl equation, I've eliminated x, and I'll get an equation that just has t. Let's see how that works. I've got -5 for Bob plus 4t equals positive 10 for Carl minus 6t. So now our objective is just to get all the t's on one side and all the terms that don't have any t in them on one side. So I'm going to begin by adding 6t to both sides. So I can see -6t and 6t cancels here. Adding these together, I have 10t. So -5 plus 10t equals 10. And then I can add 5 to both sides to get this 5 over to the other side. So these guys are going to cancel, and I have 10t equals 10 plus 5, which is 15. So dividing both sides by 10, I see that t equals 15 over 10, which is 1.5 hours, or if you prefer minutes, that's 60 minutes plus half of 60 minutes, so that's 90 minutes. Now, since these equations are in hours, I want to take my hours result, 1.5 hours, and we found out when they meet, but we want to know where they meet. So let's take this 1.5 and plug it back into our original Bob equation. So that gives me that x equals -5 plus 4 times 1.5. How much is 1.5 fours? Well, I've got 4, and then half of 4 is 2, so that's 6. So this tells me x equals -5 plus 6, so that is positive 1. And since this is positive, I remember that means east, so that is 1 kilometer east of the school. So that is the algebraic method for solving this problem. It works anytime. I can use numbers that are easy or numbers that are difficult, and this method will still work. I just have to have my algebraic skills for solving an equation in one variable here, and I need to know that setting the two equations equal when I've isolated x like this lets me solve for t and plug back in. So we have two equations and two unknowns, and that is the method. The next method we want to see is how to use a spreadsheet to solve this problem, which should give us the same answer. Let's come over here to our spreadsheet. I'm going to make a column called time. Remind myself that it's in hours. And I might be interested in the time in minutes too, so I could make a time in minutes, and I'll show you how to do that. Then we have a column for Bob, his position, and a column for Carl. We'll say these are position in kilometers. Great. If I want the column to adjust so I can see everything, I can just give a little double click like this when I've got the little arrow, and it adjusts to fit the full width of the text that I entered. So let's begin at the beginning of time. We'll call it 0. And how much would we like our time to increase? I want to use an automatic function here, so I'm going to say that all my times going forward are equal to the time I started with, the time that I just had, plus some small amount. Let's say, a 1/10 of an hour. So that would be 0.1 hours. Remember now that I have a formula like this. The formula is applied relative to each cell, so I'm taking the cell above me and adding 0.1. I move my cursor until I get a cross by coming into the lower right-hand corner when the cell is highlighted, and I drag it down. I've got an hour there. I know I need an hour and a half from just solving the problem before. I'll drag it a little bit past that. We'll go to 2 hours. Now, how do I convert time in hours to time in minutes? Well, what would 1 hour be? It would be 60 minutes. So this column will equal the hour column times 60. That is pretty easy. Dragging this down, and let's check. 1 hour is 60 minutes. 2 hours is 120 minutes. Half an hour is 30 minutes. That looks good. Now for Bob, let's look over here to our equation. I know that this position must equal, remember formulas always have to begin with an equal. Where does he start? -5 plus 4 times time. Time is in column A, and remember that we're talking about hours here because we have kilometers per hour. So I'm going to use the hours column, not the minutes column. So I click in A2, and I know for Carl, his position, where does he begin? He begins at +10 minus his velocity, 6 kilometers per hour, times how many hours go by, so -6 times, again, column A gives me the time. And now, just highlighting both of those, we get our little cross icon and drag down, and we can see what their positions look like. So I see that Bob begins with a west position, so it's negative, and it's getting less negative. And Carl begins with a positive position that's getting less positive, so they're going to meet each other. And let's check, where do they meet? We said it was at 1.5 hours. Checking that, I see that that has not given me the same result, so let's check this. -5 plus 4t. This velocity was not 5. Not 6, it was 5. So let's check that. Reapplying the formula, I need to drag this down again. And now we see the result we expected. So it's always good to double check these things. I have at 1.5 hours, they both have a position of 1 positive, so it's east, and that is the same thing that we saw. So these are the two methods. I have my spreadsheet and I have my algebra. They both work. The advantage of the spreadsheet, well, one of the advantages is I can use it to make my stop motion animation. A disadvantage is if I picked a 1/10 of an hour and they didn't meet in an even multiple of tenths, then I wouldn't be able to easily find this position where they're equal. So you might have to mess around with the step size of time that you're using when you use this discrete method versus this method, which is fully continuous in time. It can give me an answer that's any time. And we might want to know, how can I graph this? So to insert the graph of these two positions versus time and to see where they intersect, I've noticed that the spreadsheet gets a little bit confusing to set up if the columns that we want to graph aren't next to each other, so I'm going to grab this column B and drag it out of the way, since I'm not really interested in the time in minutes right now, but in hours. So I'm going to graph these three columns. I click in the A, now I'm holding Shift and clicking in the C to highlight all three. Now let's insert a chart, not a column chart, but a scatter chart. And there it is. This looks like just what we want. I have Bob's position in kilometers and Carl's position in kilometers in blue and red respectively. And Bob is beginning 5 miles west. Carl is beginning kilometers, 5 kilometers west, and Carl is beginning 10 kilometers east, and I see that the slope for Carl is what I know the slope should be, -6, and the slope for Bob is +4, just as we expected, and they intersect at 1.5 hours with a position of 1 kilometer.